All right, so the next thing we're going to do with our line, like I said, beyond just making predictions, we want to look generally at what the line tells us about the relationship between our x and y. So that's going to be breaking down this slope-intercept formula and what we already know about slope and intercept from algebra. So again, we tend to reverse the equation of the line in statistics. So our b naught, the thing floating out here without an x, is our intercept. And our b1, the thing that's touching the x, is our slope, right? And just know we can calculate these if you wanted to by hand. We are never, ever, ever going to do that. But I'm giving you the formulas here. So to calculate your slope, it's your correlation times the standard deviation of your y's divided by the standard deviation of your x's. And then the y-intercept is going to be the mean of your y's minus the slope times the mean of your x's. So this is how this is calculated numerically. And then a cool note here, it's always going to pass through the mean of the x's and the mean of the y's, that point. So let's see the part we care about here. This is 100% something that should be on your note card. I kind of want to move my little screen over. I don't know if I can. How do I grab you? Come on. Yes. This is something that should be on your note card. Oh, God. Or whatever. Note card. So this is another fill in the blank, just like our correlation coefficient interpretation. This is just a way to make sure that we don't have any mistakes when it comes to interpreting our slope. It doesn't mean you have to use this, but it does mean that if you use this, you probably won't get yourself in any trouble. So let's look at our slope interpretation, at least, and then our y-intercept interpretation for that previous example. So remember, this is systolic blood pressure versus weight. So this is our weight influencing systolic blood pressure. So just quickly thinking about what this would mean in terms of a line, if we were going to graph this, right, we would start at 1.1 because that's our intercept, and then we go up, just out of the ability to write, 0.764, and then we go over 1, right, because this is all over 1. And we find the next point. We do the same thing to get this linear line. So that's exactly what we're just going to write in words in context with these two different sentences, is this idea of, okay, rise over run, change in y over change in x. Got it. So for the slope, for every, I don't know why I put each up there, I always like every, for every 1, and then our x was weight and weight was in pounds, so for every 1 pound increase in weight. So the only pieces I put into this little equation so far are my units for my x variable, our y variable, which is systolic blood pressure, is predicted to, now increase or decrease is all determined by whether our slope is positive or negative. So in this case, since we have a positive slope, and we could see that in our scatter plot, we're going to say increase by the slope, which you want to put the absolute value, because if you say decrease, you've already told me the slope is negative, 0.764, and then our units of y, which, as we said before, millimeters mercury. So we put increase, we inserted our slope, and the units for our y. So this is telling me every pound of weight you gain, we're going to predict that your systolic blood pressure goes up by 0.764. So this gives us a lot of information, right? This is the general relationship between our x and y, much more so than saying as weight increases, so does systolic blood pressure. So on a test, what are you going to get points for? Well, a lot of this. One thing I always give a point for is this idea of putting something in to say that this is just predicted. This is just approximately. This is not a guaranteed thing that if you gain 1 pound, this is what's going to happen. This is sort of what we think plus or, approximately. Because, right, statistics is all about kind of guesstimating. And then our y-intercept here, you can go by that little sentence. For our x variable was systolic, x is not systolic blood pressure, for a weight of 0 pounds, so all I've done is put in my x variable and my units and left off an of F and of, we would predict Y variable, that was our systolic blood pressure, to be 1.1 millimeters mercury. So again, Y variable. So here's the thing. The Y-intercept is not always going to make sense. Look at this one, right? What does it even mean to weigh 0 pounds? Is that possible? No. What is it? Like, this person is not alive. This is an insane thing. So while I can write this sentence doesn't actually make any sense. There are contexts where it would, right? If we're thinking again about time spent studying and exam score, then I would like to have that prediction. If you spend 0 hours studying, here's what I predict your exam score will be. That's an actual useful thing, right? Whereas this one is not terribly useful.